All right.
Let's see. I gotta pull up my stuff.
We're doing stats again today.
Yes,
All right.
because I am doing my review for this unit. And I have some things that I'm not understanding with it.
Okay.
Let's see. It was. Hopefully that's it. Let's see. Yeah, that's it. Now just screen. Can you see my screen?
Yeah.
This is one that I'm not understanding. Honey, can you turn that down, please? Thank you. He's finished with school for the day.
A certain standardized test math scores have a bell-shaped distribution with a mean of 520 and a standard deviation of 114. Or percentage of standardized test scores is between 178 and 862. So for something like this, you know to use the empirical rule. Do you remember that?
It is E something -1.
No, it's not a formula. We have a bell-shaped distribution, and they've given us a mean and standard deviation, but very little else to go on. So we have to use something called the empirical rule to kind of approximate our percentages. So what we have to do is we have to draw a bell shape, then cut a line through the center. That will be our mean. I'll do that. Currently writing on my tablet. Okay. Then do 1, 2, 3 standard deviations to the left. And 1, 2, 3 standard deviations to the right. Empirical rule is always a huge pain because you have to draw.
Yes, I agree.
Well, sometimes you don't have to. Like some teachers, they like print out these templates that you can work on. It's, and I wish more teachers did that.
Yeah, me too. Let's see. Which page is this on?
Okay, so you see this wire?
Yes.
Yeah, so you got to set up something that looks like this. Now, right down the middle, that's where the mean is going to lie. So 520.
So would I do that with StatCrunch?
No. This is something you either have to just draw out or, I mean, technically you could do it without drawing, but it might be a little hard to make sense of unless you like come up with a solution of your own. And I'll mark that as mean. Okay, standard deviation of 114. So down here in the middle, there's my mean. Now to the left, sorry, that way, because I'm facing the other way. To the left, 1, 2, 3 times, I'm going to start subtracting the standard deviation from the mean. So 512 minus 114. Need my calculator for that. 120 minus 114. 406. Subtract another 114. 292. And subtract one more, 114. 178. And I'll mark these as -1 standard deviation, -2 standard deviations, and -3 standard deviations. So you see that?
Yes.
Yeah, okay. Now I'm going to start going to the right, which is standard deviations above the mean. So I'm going to look at 520 and then add 114, 520 plus 114, 634. Plus another 114, 748. And plus one more, 114, 862. And I'll call these +1 standard deviation, +2 standard deviations, and +3 standard deviations. See that?
Yeah.
Yeah. So I'm left with this thus far. When dealing with the empirical rule, there are some like set in stone things. To the left, or I should say, one standard deviation below the mean comprises 34% of the data. 34% of the data also comprises one standard deviation above the mean. Two standard deviations below the mean comprise 13.5% of all the data. Two standard deviations above the mean, again, comprise 13.5% of all the data. Three standard deviations below the mean comprises 2.35% of all the data. Again, it's very symmetrical. 3 standard deviations away from the mean comprises 2.35% of all the data above it. And then beyond that to the left and right is 0.15% each side. So on the left-hand side, more than 3 standard deviations away, 0.15%. On the right, more than 3 standard deviations away, 0.15%. Okay, do you see that?
Yes.
Yeah. And just as some general rules that will help you very quickly. What is that? My phone. Unavailable. Okay. Let me mute my phone. Okay. Sorry about that. Just as a like kind of a shortcut, if I can fit it. All data lies within one standard deviation, or 68% of all data lies within one standard deviation away from the mean. And that's what you would get if you added the two 34% on each side, right? See that? 34%, that's 34%, 68%. And then if you kept going, 95% of all data lies within two standard deviations, and 97.35% of all data lies within three standard deviations. Or no, 99.7% of all data lies within three standard deviations of the mean. And I don't really have room to write that, but yeah, it's just a short way of being able to add like 34, that's one less, one greater, that's your 68. 13.5, 34, 34, 13.5, that would be 95. 2.35, 13.5, 34, 34, 13.5, 2.35, that would be your 99.7. Okay. So now we're ready to answer the question, what percentage of standardized test scores is between 178 and 862? So 178, that's way over here. 3 standard deviations less than the mean, right?
Mhm.
And 862, that's way over here. That's 3 standard deviations above the mean. So because it's going to be all these percentages added up, the 2.35, the 13.5, the 34, the 34, the 13.5, and the 2.35, that would come out to 99.7%. So that's what the answer is going to be here.
All right. Is that a comma or is that a dot?
That's a comma.
All right.
Yeah.
And then what percentage of standardized test scores is less than 178 or greater than 862?
So this is basically asking what's left over, right?
Mm-hmm.
Anything outside those two numbers they gave us in the first part. So if you wanted to, you could just say 100% minus 99.7% and get your answer.
Let me do that. 100 minus 100% minus 99.7% equals, and it gave me 0.003, which what would that be as a percent?
0.3%. You just multiply it by 100, but yeah, 0.3%. And you don't have to convert them or anything because you're just sticking with percentages. You could just say 100 minus 99.7, you get the same thing.
So it's 0.3%.
Yeah. And again, that was just what was left over. If you look literally at what it's asking, less than 178, you would look over here. That's 0.15%. And greater than 862, you would look over here. That's also 0.15%. And 0.15 plus 0.15 is your 0.3.
All right.
What percentage of standardized test scores is greater than 748? So we just look for 748 on the bottom here. There it is. So we're going to add up the two percentages to the right of it. So 2.35 plus 0.15.
2.35 plus
0.15.
0.15. And that'd be 2.5.
Yeah, 2.5%. All right, good.
Volume data represents monthly performance in minutes. Yeah, I sat there for a little bit trying to figure out what to do on this, because I wasn't sure if I was supposed to add that mess up or what.
You'll open this data in StatCrunch.
Would I go to columns?
Yeah, columns. Good. Now, something you're going to want, three things specifically. You'll want quartile 1, quartile 3, and the IQR. Technically, if you're finding the IQR, you don't really need quartile 1 or quartile 3 either. But, well, yeah, you would. Never mind. Okay. So if we're finding the upper fence, which is what they're going to use as the cutoff point, we need these three numbers. Do you remember the formula for calculating the upper fence?
No.
No? All right. Upper fence, I'll just call it UF, is quartile 3 plus 1.5 times the IQR. See that?
Mm-hmm.
Yeah, and we actually don't even need quartile 1. It's just that usually with these problems, they want to know what both the lower and upper fences are, but they just want the upper fence for this one. So we're just going to plug those numbers into the equation.
So I would add this plus 1.5.
Yeah, I'll plug in the numbers here. So UF equals our 486.5 plus 1.5 times 92. Like that.
So that was, oh, I see now. So 486.5 plus 1.5, and then I'll plug in IQR, which is 92, and that would equal 624.5.
Yeah. You'll round to the nearest minute. So the nearest whole number.
That would be 625.
Yeah, 625. Okay, good.
As long as you know that formula, it would be pretty easy.
Yeah, it's not that bad.
What did I get wrong? Oh, I see now. I know how to work this problem. It's just remembering which number is predicted and which number is average.
Okay. Let's see.
I can do a.
That's weird. It's not saying. It's not saying interpret the slope. For that first part under B, that's what it's asking for. It's asking you to interpret the slope. I mean, next to B, it says interpret the slope and y-intercept, but do you see how for the second part of part B, it says interpret the y-intercept, so select the correct choice below?
Interpret the y-intercept right there.
Yeah, there should be a sentence above that first part that says interpret the slope, so select the correct choice below, blah, blah, blah.
It does.
It's not there.
Yeah, and that's where.
But yeah, that's what B is asking for. The slope is going to be whatever your coefficient of X is. In this case, the negative 0.050.
I'm going to do a similar question just to make sure that I know how to do it.
Okay.
And then I go here, open stack count. Because I got to know all this because I have a midterm I got to get done before Saturday. And I am not looking forward to it at all. Me and you. Isabella, stop. All right, and this is to the third decimal, so 1, 2. And your little copy and paste thing that you told me on our last meeting has helped me out a lot.
Good.
All right, and then go back. 1, 2, 3. What would I change that 9 to?
The 9 would get bumped up to a 10, which would in turn bump up to 2. So 30.
30.
Yeah.
That's what I thought. I was making sure. All right, so then I backspace over those, and that would be it.
Yeah, good.
All right, let's see.
Oh, it does say interpret the slope. It's all in that one sentence. It says interpret the slope and y-intercept if appropriate, then immediately it follows that by saying interpret the slope. Okay.
That would be 0.046. and it would be average.
For every unit.
Let's see.
Okay, it's not B.
No, it's that one.
Yeah, what you need to do is you need to pay attention to whatever your x is, because the slope is the coefficient of x. So x in the context of this problem is commute time in minutes, right?
Uh-huh.
So for every unit increase in commute time, the index score falls by 0.046 on average. Yeah. And because it says falls by, that's why you don't need the negative. Okay, good.
69,030. 69.
Yeah, when interpreting the intercept, you're assuming that x is 0. Sometimes, though, it makes no sense for x to be 0. And in this case, we're talking about a commute time in minutes. So in what context would a commute time in minutes be 0 and make sense?
For commute time of 0. It's predicted to be about 69,030.
I'm just asking you, in what scenario would it make sense for a commute time to be 0?
I don't think it would ever make sense.
There's a way it would make sense. And it's become increasingly more common during the pandemic started. When the pandemic
Delivery.
started. When you're working from home.
Yeah, delivery. For
Yeah,
other people to bring it to you.
Yeah, if you're working from home, you don't have to commute anywhere. So you don't have a commute time.
Yeah.
So yeah, that's why you can actually say if your commute time is 0 minutes. Otherwise, you would say it's not appropriate to interpret the intercept. Like, scroll down a little bit.
I was scrolling up because I was getting the formula.
Okay. You see E, it's not appropriate to interpret the y-intercept.
Yes.
Because a commute time of 0 minutes does not make sense. In this problem, it does. But I know there's one question in particular that talks about how the weight of a car affects gas mileage.
Mm-hmm.
And in that particular problem, it doesn't make any sense to interpret the y-intercept because you can't talk about a car that weighs 0 pounds, right?
Yeah.
And then you were working this out, you just plug 25 in.
Yeah, you just plug in 25.
Yeah, into the equation you had before.
Yeah, 67.88 rounds to 67.9.
Yeah. Sorry for being real wordy there. I just want to make sure that if you see something like that, you'll know how to tackle.
Oh, that's fine. I'd rather you do that than us not talk about it and then maybe stuck, especially during the midterm.
Yeah.
Because that would really suck to be stuck on your midterm. Was not that plus 69.030. All right, suppose Barbara has a 20-minute commute and scores 67.3 on the survey. Is Barbara more well off than the typical individual who has 20-minute commute? I think it's no, and the answer is 68.11.
Yeah, she's scoring lower than what someone should be scoring. She's not more well off. You're only rounding this to one place.
Okay, apparently it's the other one.
No. You round it to one place.
So round it to 10.
Well, just one. Yeah.
Oh, that's why I got right, because I had one extra one. Right. sample space.
Let the sample space be the numbers 1 through 8. Suppose the outcomes are equally likely. Compute the probability of the event, an odd number.
I'm sorry about that.
It's fine.
My phone. I thought I had it on silent. Hush, Isabella. That's my daughter's favorite ringtone, so she was singing it. All right, compute the probability of an int would be an odd number. It would be 1, 2, 3, 4 out of 8.
Yeah, the odd numbers between 1 and 8 are 1, 3, 5, and 7. That's 4 over 8.
4 over 8, which equals to 1/2. And that into a decimal is 0.5.
Mm-hmm. Good.
And I got all these right because I remembered your little thing that you wrote on the screen several times about you add and then minus the E and F.
Right.
I got that one, that one. They had like 2 in a row just like it.
The university conducted a survey of 369 undergraduate students regarding satisfaction with student government. Results of the survey is shown in the table by class rank. If a survey participant selected at random, what's the probability he or she is satisfied with student government? Okay, so
is that she is satisfied.
yeah, how many students were satisfied?
Satisfied, you would have to add all, oh no, you wouldn't, there it is, 220.
But that is what you would do otherwise, yeah, if they hadn't given it to us. So yeah, there are 220 students who were satisfied.
So would you do 220 divided by 369?
Yeah, 220 divided by 369.
And then 3 decimals, so that will make it 0.596.
Mm-hmm.
Not take my 5. I guess I didn't push it down far enough. That is a dot, right? That's not a comma.
Yeah.
Just making sure because I tendency to do commas instead of dots for some reason. The survey participant is selected at random. What is the probability that he or she is a junior? So I would add these together.
Right.
Actually, I wouldn't have to because here's the total.
Yeah.
97 over 369.
Yeah, over the total again.
Not getting that stuff in the floor, are you? She's playing with kinetic sand. 0.263.
Right.
0.26.
Good.
The survey participant is selected around what is the probability that he or she is satisfied and a junior? 40, oh, not 47, 62 over 369.
Yep. Good.
And that would be 0.168. he or she is satisfied or a junior.
So here is where you have to treat it kind of differently. So let's add up the satisfied row. They give us that straight up. It's 220, right?
Yes.
And then we're going to look at the junior column, but not add the 62 because the 62 was already taken care of when we tallied the satisfied. So just add the 17 and 18.
Yeah,
So 220 plus 17 plus 18.
220 plus 17 and 18 equals, and then I would divide that by 369.
Right.
60.
Okay, good. Does it make sense why we did that?
Do what?
Did it make sense why we did that?
Yes, because we had already had 62, and instead of adding 62 twice and then having to subtract 62, then divide 369, it saves you a step.
Exactly. Yeah. Very good.
See, the probability of 8 heads in a row when flipping a coin. Okay, I remember we'd done a problem like this before. I'm trying to remember what the formula is. Oh, Lord. Today's been a long day. Let's see. I think it's something to do with PE, and then maybe minus P or something on the end.
It's not the addition rule.
All right.
This is the multiplication rule, technically. Because you're saying heads and heads and heads and heads 8 times.
Yeah. So what'd you do? See, each coin has 2 sides, and then you're doing 8 heads. So what'd you do? You wouldn't times it.
You sort of do. Okay, well, let's start from the beginning. What are the odds of you getting a heads?
50-50.
Yeah, 50-50. So that would be a 0.5. And then if you're doing it 8 times, you would be saying 0.5 times 0.5 times 0.5 until you
or 0.5 to the 8th power.
That's the easier way of going about it. Yeah. So just do 0.5 to the 8th power, and you'll have it.
And that gave me 0.00390625.
And they want 5 places.
And then 5 places are 1, 2, 3, 4, 5. This is what I think it is. 0.00390. Now that 0 would turn into a 1.
Yeah, there you go. Good.
Consider the event of a coin being flipped 8 times. If that event is repeated 10,000 times, you would multiply 10,000 to this number.
Yep.
Around to the nearest whole number. 40.
Not 40. Well, wait.
39.0625.
I think they want you to. Okay, well, yeah, it'll stay 39.
It'd stay 39.
Yeah, because whether you
What?
use the rounded one or not, it's going to be rounding down to 39.
Alright.
Yeah.
Why does it not get rounded to 40?
The decimal place following the 39, that has to be a 5 or greater.
Because it's a 0, it stays 39.
Yeah. Or if it's
Okay.
a 1, if you use the rounded number from the answer.
That makes sense now. All right, this is that card problem. Let's see. I have that stuff wrote down in my notes
Okay.
because my teacher's done pretty much the same thing you've done on the screen, like the following week. She's always a week behind me for some reason. Which that could be good. It's better to be ahead of your teacher than behind your teacher.
Suppose you don't want to get too far ahead though.
No.
You might start forgetting what she goes over.
Yeah. Let's see. That's not talking about cards. I don't remember which lesson the cards is in. Let's see. Suppose you draw a card from a deck. I just found it as soon as I said that. Ain't that great? All right, suppose you draw a card from a standard 52 decks and then roll. Okay, that's supposed to be a die instead of addy. She didn't space it. Okay. The events draw a heart and roll an even number are independent because the results of choosing a card do not impact. She didn't write none of this stuff down in the notes. Well, that doesn't do me any good at all. All right, can you write the stuff down about the cards? And I'm going to write it on the back of this.
All right.
That way, when I have these notes for my midterm, I'll know. I'm sorry, I'm having to have you write it again.
It's okay.
Oh man, I didn't win. That sucks.
You see that?
I didn't win the survey for this week.
Survey.
The student survey that they have you go and fill out something on there, and it says the media press survey, where they each week they pick like so many winners. I forget what they get. But you get a prize for winning. I was hoping I was going to win. And this week is the last week. Well, that was nice. You hear my sarcasm.
Yeah.
And that survey took me about 15 minutes to do.
Yeah.
So I wasted about 15 minutes for nothing. 4 suits. 13 cards each. Okay. Spades. Black. Clubs. Black. And diamonds. Red. Our meeting is tomorrow, correct?
Yeah, tomorrow at 11.
All right, I was making sure it wasn't on Wednesday because my daughter has to go to her school and take her last test. And I have a lot of anxiety about it because I don't want her being around a bunch of germy kids.
Yeah, I don't blame you.
All right, I have that wrote down. So the probability that a card drawn from a standard 52 card deck is a spade, and they have, what's it, 4 cards in each column?
There are a couple of
Or
ways you
was
can
it,
think about this.
or is it 8?
There are 13 spades. You can, yeah, each of these suits has 13 cards in it. So you could do 13 over 52, 13 cards that are spades over 52 cards total. Or you could think of it this way. Spades is just one of 4 suits, so do 1 over 4. You'll get the same answer either way.
So technically I was right with the 4.
Yeah.
So it's 1. Oh, you gotta do it as a decimal. I hate having to do that. They just have something against fractions. That's all it is.
Yeah, 0.25. Good.
The probability drawn that a standard 52 is a spade, given the card is black, is there's 4 cards that are black and 4 cards that are no, the spades. So 4 suits. There's 13, so that'd be 13 over 52.
Mm-mm.
No, wouldn't be 52. Let's see.
If they give
It'd
you a
be
given,
12. Would it be 12 over 51?
no. If you're working with a given, that means you're only going to be looking at whatever your given is. In this case, the given is that the card is black. So how many suits are black?
2.
2. There are only 2 suits that are black.
So
And one
2
of those is
over
spades.
13.
No. We have 2 black suits and one of the black suits is spades. So what's 1 over 2?
1 over 2.
Yeah.
I'll put that off the top of my head. 0.5.
Yeah, 0.5. So that's your answer. Another way you could think about it is there are 13 cards in each black suit. So 13 plus 13 is 26. 13 over 26. 13 spades over 26 black cards total is also 0.5.
Days are cloudy. Also in the same sequence, cloudy and rainy. What probability that it rain on a selected day in August would be rain if it is cloudy? Well, how can it be? So in August, would you do it by how many days are in August?
No. This is a formula. I'm going to use C and R for cloudy and rainy. So the probability rainy if cloudy equals the probability that it is rainy and cloudy, or cloudy and rainy, I guess. Yeah. Over the probability that it's cloudy.
Cloudy / rainy. That way I'll kind of know what the problem's about. Isabella, what are you listening to? Okay, I got that wrote down. So let's see.
So the probability that it's rainy if it's cloudy equals the probability that it's cloudy and rainy divided by the probability it's cloudy.
So would you multiply 46% by 41% and then divide that
No,
number
this is just straight up division.
Right.
So what's the probability that's cloudy and rainy?
Cloudy and rainy, 41%.
Yeah, and what is that as a decimal?
41%. 0.41.
Yeah, so you're going to say 0.41 divided by, and then what's the probability that it's cloudy?
If it's cloudy, 0.46.
And what is that as a decimal? Oh, you just said what it is as a decimal. Sorry.
Yeah.
But yeah, 0.41 divided by 0.46.
0.46. And that will be 0.891.
Yeah, 0.891. Good. So if it's cloudy, the odds are pretty good that it's going to rain too.
Yeah. So suppose life insurance sells a 190,000 1-year term life insurance policy to a 20-year-old female for 280. The probability that a female survives the year. You do that by NAMI or whatever, don't you?
Not here.
Not here. Compute and enter the expected value of this policy in the insurance company. So
okay, you see this? I'm making a little table kind of.
uh-huh.
Okay, so we have a value column and a probability column.
Yes.
And a lives row and a dies row. Okay, so this is for the insurance company. So if this lady survives the year, how much is the insurance company making off of her? How much is she paying?
280.
Yeah, $280. So in the value column, lives row, we're going to put 280. And then what are the odds of her living that year?
Would it be the decimal number?
Yeah, 0.999. 591.
Isabel, I need you to get the sand out of the floor. Look under your chair.
I'll get that.
Okay, so the odds that she survives the year, 0.999591. The insurance company makes $280 off of her if indeed she survives the year. Now, if she dies, this is a $190,000 insurance policy, right?
Mm-hmm.
So they're going to be losing that, but they still have the $280 that she gave them prior to her death. So what's the difference?
To lose.
Yeah. So what's the difference between 190,000 and 280?
Say that one more time.
The difference between 190,000 and 280.
Let's see. 190,000 minus 280 is 189,720.
Right. And because this is a net loss, we're going to make it a negative number. So negative 189,720.
I should have done 280 minus that number to get the negative.
Yeah, that'd be the best way to go about it. So I'll put that there. Give me just a second.
Oh, I gotta plug up my computer. Hold on just a second. Is your battery still good? Yes. Oh, good. Good thing it was right behind the computer.
Okay, so her odds of surviving the year are 0.999591. What are her odds of dying?
Would I divide that number by the 189,000?
No. It's the complement rule, right? If the odds of her living are that, the odds of her dying will just be 1 minus that, whatever's left over. So 1 minus 0.999591.
0.999591 minus 1 is negative 0.000409.
Yeah, but not negative, because this all has to add up to 1. These
Alright,
two probabilities.
So it's positive 0.00409.
Yeah, and I've reflected that in the little table. All right, so this is what you're going to be putting into StatCrunch yourself. So go to question help in StatCrunch. And you don't need the words, just the numbers in the right places. So in the top leftmost cell, you'll put your 280. Right. Yeah. And now you're going to go to stat. Now, because you're working with 2 rows or 2 columns of numbers that some of which are not integers, they're decimals, you're going to go to calculators custom.
Customs all the way down.
Yeah. Your values will always be in the first one and the weights in the second. And then the expected value is just going to be whatever your mean is.
So this would be my answer, but would I change the 2 to 3 and 9 to 0, or just keep it like that?
They want it like dollars and cents, so just keep it like that. $202.29. Okay, good.
Which of the following interpretations of expected value is correct? Insurance company expects the profit It would be this one because that's the one that has that answer.
Yeah, it's the only one that has the correct total. So yeah. All right, good.
That's kind of obvious.
Yeah. I'm gonna have to stop there because the lab closes at 4.
Yeah, it's 4:05. But thank you for helping me, what you have helped me with today.
Yeah, you're welcome.
And I will see you tomorrow.
Yeah, I'll see you tomorrow. Okay, you have a good evening.
I have to have breakfast and drink some coffee to wake myself up.